For this lesson, we're going to be learning about something called indirect measurement, which you actually did in your first assignment, but really it's using what you know about similar triangles to find a measurement that's missing. So here's our first problem here. We can see that these two triangles are similar because of angle, right? We have two sets of congruent angles, so we know that they are similar. So really, we just need to match up corresponding parts as a proportion. So for instance, 22 does not really match up to anything. 22 would match up with this side, and that doesn't help us. So we're going to use 26 over 10 is equivalent to, then I'm going to go, so I went left triangle to right triangle. I'm going to go left triangle to right triangle again, and be 18 over x. So I can just cross multiply there, and you should get x equals 6.9. That's really all there is to it. Here's another example, and I brought this in because people are starting to find patterns. You have to be very careful. So in this one, we're assuming, I'm going to tell you that the triangles are similar. We are going to compare that top triangle to the bottom triangle. Okay, so we have the small triangle up top compared to the whole overall triangle. So let's solve for x first. I'm going to solve for x first. I'm going to use the left side and the right side, and when I refer to the two triangles. Okay, so solving for x, the left side of the small triangle is 4. The right side of the small triangle is 3. If I look at the large triangle now, the left side is the entire side here, so that's actually the quantity of x plus 4. The right side, the whole side, is going to be equal to 12. All right, so when I cross multiply, I end up with 3x plus 12 equals 48. Subtract 12 from both sides, and I have 36. Divide by 3, and I get x equals 12. I'm going to write that in here just because. All right, so now what I want to do is solve for y. All right, so now y is the bottom of the small triangle, and we're going to compare it to the bottom of the big triangle. And this I'm going to compare the right to the bottom and the right to the bottom. Okay, so the right side of my small triangle is 3. The bottom of the small triangle is y. Then I compare the right side of the big triangle is 12. The bottom of the big triangle is 18. All right, so let's go ahead and cross multiply. I have 12y equals 54. And I need to divide by 12, and I get 4.5. All right, so those are pretty straightforward indirect measurement, but there's some real application in life as well. So here's an activity if we were at school we were going to do, but really what happens is you place a mirror on the ground, okay, and you look down into the mirror and you start to back away from the mirror. Okay, so you're backing away from, this is the mirror, you're backing away, and you back away until you can actually see the top of the object that you want to find the height of. Okay, so this is his vision going down into this mirror and seeing the top of this pole. What happens is this angle right here is called a reflective angle. Okay, it's the kind of angle that exists like when you're playing putt-putt or when you're playing pool. Okay, so basically says that the angle that, in this case the vision, bounces in at is the same angle that it bounces out at. Okay, so those two angles are going to be congruent. We're also going to assume that our flagpole was installed correctly and it's perpendicular to the ground, and that we are standing straight up, and we are perpendicular to the ground as well. So these two triangles are similar because of angle. So then I can just set up my proportion. So 6 over x would be equivalent to 2 over 8. So 2x equals 48. Divided by 2, you get x equals 24. So in our case here, the flagpole is 24 feet tall. Indirect measurement in real life can also be done with shadows. Okay, so here are two shadows, right? The shadow of the person and the shadow of the light post. I can determine, these measurements have to be taken at the exact same moment because as the sun moves throughout the sky, then the shadow does change. So you can't take your height, now and then 10 minutes from now, the height of the object, because that will change. So we can go ahead and set up our proportion. We would have 6/18. So it's the shadows is equivalent to 5.25 over x. And we can go ahead and cross multiply. So we'd have 6x equals 18 times 5.25 gives me 94.5 divided by 6, and we get 15.75 feet in our case. All right, so what I'm going to have you do is there's two different practices. The first one is a maze. Okay, so you're going to use that. You're going to do that in Google Slides, and you're just going to use the line tool to draw your path through the maze. And then I have a second one that involves some more algebraic expressions instead of just straightforward, just a side length. So that's going to be in Google Sheets. So there are two assignments for this lesson.